Okay, Unit 6 is on exponential and log functions. This unit reviews the difference between quadratic and exponential functions. It also explores how to find the inverse of an exponential function called a logarithmic function. So on page 3, we are going to learn today about how to explain how the exponent changes the value of the number. And we're going to compare and contrast exponent form and radical form. The product of powers says if you are multiplying a value with the same base, so in this case it's base A, you can just add the exponents. So this would be a to the m plus n. So you're just adding the exponents. So in our examples here, these have the same base, so we can just add the exponents. So this becomes 3 to the 5th power. And then if you type in 3 to the 5th power on your calculator, it simplifies to 243. You're not going to need to show the work where these are being added, but you can show this part and then the final answer. So you don't have to show the adding, just write what you get when you add and then the final answer. So over here, we're doing x squared with an x, so that's going to become x squared plus another x. Here we have 1y with 5 y's. So we're going to add those together with like bases. So this is going to become x to the 3rd, y to the 6th as your final answer. Again, you don't have to show this work. The power of a power is when you have exponents a to the m times b to the n, all to an x power. What you do is you multiply the exponent into the other exponents. So it's a to the m times x, b to the n times x. So you're multiplying the exponents by showering the power. This only works when you don't have a plus or minus inside the parentheses. So in the examples, we don't have a plus or minus, so we can go ahead and shower the power. So our base is 2. We would multiply the exponents 3 times 4, and we're going to get 2 to the 12th power. Type that into your calculator, 2 to the 12th power, you're going to get 4,096. Again, you don't have to show what you're multiplying, you just need to show 2 to the 12th and then the final answer. Over here, we're going to shower the power to each one. So it's x to the 2 times 3, and then y to the 4 times 3. That's going to give me x to the 6th, y to the 12th. Again, you don't need to show this work. If you have a negative exponent, a to the negative n power, to make it a positive exponent, you move the base to the other side of the fraction. So it becomes 1 over a to the positive n. Or if you have a negative exponent on the bottom of a fraction, you would move it to the other side of the fraction by putting it on top. So it's going to become a to the positive n on the top of the fraction. So you're flipping the base to make the exponent positive. So first example, we're going to make the 5 positive by moving the 4 to the bottom of the fraction. So it becomes 1 over 4 to the 5th power. And 4 to the 5th power can be simplified, so it becomes 1 over 1,024. Over here, we're going to have to shower the power. So it's x to the negative 1 times negative 3. That's going to become x to the positive 3. And then y to the 2 times negative 3 is going to be to the negative 6. You can never leave your answer with the negative exponent. So notice that the x value has a positive one, so that's going to stay on top. But the y base is going to move to the bottom, and the 6 is going to become positive on the bottom. So it's x cubed over y to the 6th. Zero exponents, if you have a base to the 0 power, it will always equal 1. So any number to 0 power is going to be 1. So 4,128 to the 0 power is 1. This one's a little bit trickier. Notice this is not in parentheses. Only the x is to the 0 power. So this is the same thing as 14 times 1, which is 14. These would have to be in parentheses in order for the whole answer to be 1. Quotient of powers, if you have a to the m over a to the n, you would subtract the exponents, only if they have the same base. So in this first example, they have the same base of 4. So we can do 4 to the 5 minus 3, which is just 4 squared, and 4 squared is 16. You don't have to show this work, you just have to show the 4 squared and the 16. Over here, these have the same base of x, so it's x to the 2 minus 6, which is x to the negative 4th. Can't leave your answer with a negative exponent, so it becomes 1 over x to the positive 4. I actually prefer to do the question, are there more 4s on top or bottom? On top. There are 2 more on top, so it's 4 squared. Over here, are there more x's on top or bottom? There's more on bottom. How many more on bottom? There are 4 more on bottom. So that's how I prefer to do it instead of subtracting. But it's up to you. They both work. Power of a quotient. If you have a to the m over b to the n, all to the x power, you would shower the power into both the top and the bottom. So this becomes a to the m times x over b to the n times x. So you're multiplying by the shower of the power to the top and the bottom of the fraction. Students always forget to do it to the bottom of the fraction. So in our examples, this 2 is going to shower to both of the top and the bottom of the fraction. So it's going to become 3 squared over 4 squared. And then that simplifies. 3 squared is 9 and 4 squared is 16. Over here, when we shower the power, you're going to multiply the exponents. So it's going to become x to the 2 times 3 over y to the 4 times 3. So it's x to the 6th, y to the 12th. So now we're going to combine all of these properties. So notice first we have to figure out how many 2's are on top. So that would be adding the exponents. So 2 to the 4th times 2 to the 8th is 2 to the 12th power over 2 to the 5th. Are there more 2's on top? There's more on top. How many more on top? Well, 7. Or you could do 12 minus 5 is 7. And then 2 to the 7th power is 128. For part B, we have to shower the power. So we have 11 to the 5 times negative 1, which is negative 5. And then 11 to the 8 times negative 1 is negative 8. If this is a negative exponent, it's going to move the base 11 to the bottom. And this is going to move the base 11 to the top. So these are actually going to flip. So it's going to become 11 to the positive 8 over 11 to the positive 5. Are there more 11's on top or bottom? There's more on top by 3. Or you can do 8 minus 5 is 3. And 11 cubed is 1,331. Part C. Notice we have the same base, so we have negative 8 times negative 8 cubed. That means so we have negative 8 being multiplied 4 times. So when we type this to our calculator, make sure you do parentheses to include the negative, and you should get 4,096. For this one, Notice they're all base e, so we can add the exponents. So it's 5 plus negative 8 plus 6, which combines to make e to the third power. You may remember that e is a special number like pi. Our calculator will figure out what e to the third power is. E is a natural occurring number. It occurs in economics and other areas as well. So we're going to figure out the approximate value of e cubed. To do that, on your calculator, you're going to see e to the x in blue. So you have to go to second, e to the x. When you type it in, it just has e to a blank spot. You have to type in the exponent. So we're going to type in e cubed by putting a 3. And then hit enter, and you're going to get 20.08553692. We're going to round that to 2 decimal places, so it's 20.09. Okay, next one, we have to shower the power with our parentheses here. So it's c to the negative 3 times negative 2, which is a positive 6, over d to the 2 times negative 2, which is going to be negative 4. So notice this has a positive exponent, so it's going to stay on top. This one's a negative exponent, so it's going to move the base d to the top, so they'll both be on top. So it's c to the 6th, d to the positive 4. This one, we have unlike bases with the 2 and the 6, so we would just multiply. 2 times 6 is 12. The e's have the same base, so e to the negative 3 times e to the 5, you would add those exponents and get e squared. Again, e is a special number, so we would type in 12, second, e to the power of 2, and you would get 88.67. For g, every single base is going to be showered with the squared power here. So it's going to become 2 squared, a squared, b squared, over, in parentheses, negative 8 squared, a to the 0 times 2 is 0. So now we have to simplify. 2 squared is 4, and this is going to stay a squared, b squared. On the bottom, negative 8 times negative 8 is a positive 64, times a to the 0 power is 1, so it's just going to be 64 on the bottom. Notice, though, you can simplify. 4 goes into 64 16 times. And notice because 64 is bigger on the bottom, the 16 is on the bottom. Okay, this one we need to multiply these first and then we can simplify. So we can multiply the 4 times 5 is 20. X cubed times x cubed, you'd add the exponent, so it's x to the 6th. Y times y is y squared. On the bottom, we would multiply, get 10x squared y cubed. So notice 10 goes into 20 twice, so there's a 2 on top. There's 4 more x's on top, so it's x to the 4th on top. And there's 1 more y on the bottom, so there's 1y on the bottom. Okay, for the next page here, we have to figure out what all of these values are, so we are able to find the square root, the cube root, the 4th root, and all of that. So 0 squared is 0, 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49, 8 squared is 64, 9 squared is 81, 10 squared is 100, 11 squared is 121, 12 squared is 144, and 13 squared is 169. You should be somewhat familiar with all of these. Cubes get a little bit harder. So this is 0 times 0 times 0, which is 0. 1 times 1 times 1 is 1. 2 times 2 times 2 is 8. 3 times 3 times 3 is 27. 4 cubed is 64. 5 cubed is 125. 6 cubed is 216. 7 cubed is 343. 8 cubed is 512. 9 cubed is 729. And 10 cubed is 1,000. You should be somewhat familiar with all of these as well. To the fourth power, 0 to the fourth power is the same as 0 times 0 times 0 times 0. That's 0. 1 to the fourth power is 1. 2 to the fourth power is 16. 3 to the fourth power is 81. And 4 to the fourth power is 256. To the fifth power, 0 to the fifth power is 0. 1 to the fifth power is 1. 2 to the fifth is 32. 3 to the fifth is 243. And 4 to the fifth is 1,024. Okay, so now that we have somewhat familiarity with all of these, we can find out what a root is. So when you have the nth root, it's going to look like this. If there is no number here, it's a square root, but we can change it to be a cube root or the fourth root or the fifth root of this base value. This is read as what number to the nth power is a? So what number to the third power is 8? Well, the answer is 2, because 2 to the third power is 8. Over here, what number to the fourth power is x to the 8th? So that would be x squared. So x squared to the fourth power is x to the 8th. Okay? For radical exponents, we're going to have two numbers this time. So we still have the nth root, but this time m is to the exponent. This can be rewritten as an entire exponent with no root, where it's a to the m over the root n. So it becomes a fraction. So in this case, this is what you're seeing. So 64 to the 1/3 is the same as the cube root of 64 to the 1 power. And what number cubed is 64? 4. This one can be rewritten. Since the bottom number is a 4, that's telling you the root number. The bottom number is the root number. So the 4 is going to go in front. And then it's x to the third power inside. Okay? So we're going to rewrite these in exponential notation. So notice the d is to the 1 power. And then we're taking the cube root of it. So it's d to the 1 over 3. Over here, ab cubed is being fourth rooted. So you can write it as a to the 1 over 4, b to the 3 over 4, like so. Or you could do ab cubed in parentheses to the 1/4 power. Either way works. For this one, we have 3 to the power of 1, and we're fifth rooting it, so it's 3 to the 1/5, c to the 2/5. Okay, this one's in parentheses, so it's going to become 3x cubed over 4. 3 over 4. You can shower the power if you want, so it's 3 to the 3/4, x to the 3/4. That's fine as well. You don't have to. This one's going the other way. We're going to rewrite it into radical notation. So here we go. The root number is 3, and it's going to be x squared inside. So the root number is 3, x squared inside. This one has a root number of 2, and it's x to the 5th power. You do not need to have the 2 written if you're finding the square root. So if you don't write a 2 here, it's okay, because it still means the square root of x to the 5th. Okay, same thing. We're writing it as a radical, so it's going to be the 4th root of x to the 1 power, y to the 2 times 1 power. So it's xy squared inside to the 4th root. Part D is tricky. Notice x squared is not inside the parentheses, so that's going to stay out in front. However, this y cubed z is going to be cube rooted. So the y cubed z goes inside of the cube root. Please notice that the cube root of y cubed is just y, so we can simplify this to x squared y with the cube root of z. That only works because these are both to the 3rd power here. So now we're going to simplify. So what number cubed is 27? 3. What number to the 4th power is 81? 3. What number to the 3rd power is 72? Well, if you're looking at the list, there is no number cubed that is 72. So when that happens, you have to factor tree. So what multiplies to 72? That'd be 9 times 8. And 9 is 3 times 3. Since you factored the 9, we're going to cross it out so we know we've broken down the 9. Now we're going to break down the 8. So 4 times 2 is 8. Since we broke down the 8, cross it off. Can't break down the 2, but the 4 is 2 times 2. Cross off the 4, you broke it down. So notice we're trying to find the cube root. So our answer is going to be the cube root of something here, since it doesn't go in evenly. So that means I'm not looking for pairs, I'm actually looking for groups of 3 or triplets. So the number that I have 3 of is actually 2. There are 3 2's. So that means the 2 gets to go out in front of the cube root, and these poor guys don't have a triplet, so they're stuck inside. So we would multiply these back together. So 3 times 3 is 9. That goes inside the cube root, and that is your answer. For D, there is no number that's to the 5th power is 64. When that happens, we have to factor tree. So 8 times 8 is 64. Breaking down the 8, that's 4 times 2. Cross off the 8 because we broke it down. We can break down 4, which is 2 times 2. Cross off the 4, we broke it down. Can't break down this 2, so we're over here. Breaking down the 8, we have 2 times 4. Cross off the 8, we broke it down. And then factoring the 4, we get 2 and 2. Cross off the 4, we broke it down. So again, notice we're trying to find the 5th root. So now I'm looking for groups of 5. So I'm going to count off. I need 5 of the same value. So we have 5 2's, so the 2 comes out. And this one does not have 5, so this one's stuck inside, so it's just 2 inside. That is your answer. For part E, the hidden number here is 2, because we're taking the square root. So you don't have to write that, but it's just a reminder. So we're looking for pairs of 2. How many pairs are in 7 R's? Well, in our little root here, there's 3 R's pairs, correct? With 1 left over, because you have 3 pairs of R in 7 with 1 left over. How many groups of 2 are in 25? Well, 12 with 1 left over. How many groups of 2 are in T squared? Well, there's only 1 group of 2 in T squared with none left over. So that is your answer. Again, you don't have to have this 2, but I won't mark you wrong if you do have it. For F, we need to figure out what the cube root of 24 is. And since there's no number that goes into 24, we have to factor tree. So multiplying to 24 is 6 times 4. The 6 makes 2 times 3. Cross off the 6, you broke it down. The 4 makes 2 times 2. Cross off the 4, you broke it down. So again, we're looking for the cube root here. So I need 3 of the same number. So we have 3 2s, so the 2 comes out. We have a loner 3 stuck inside. We're again looking for groups of 3. So how many groups of 3 are in x cubed? 1 group of x's. How many groups of 3 are in y to the 7th? Well, this one has 2 groups of y with 1 extra y left over stuck inside. So that is our answer. Okay, number 4, we're going to continue to simplify. So we have the 4th root of 16. So what number to the 4th power is 16? Well, this one does go in evenly. It's just 2. How many groups of 4 are in 12 s's? Well, there's 3 groups. How many groups of 4 are in 16 t's? Well, that would be 4 t's. Notice nothing's left inside, so that's our answer. Over here, we're doing the 5th root. We have how many groups of 5 in a to the 10th power? We have 2 of them. How many groups of 5 are in b to the 8th? Well, we have 1 group of b's with 3 b's left over. So that is our answer. Number 5, to simplify with a fractional exponent, you should rewrite it as a root problem or a radical problem. So we are doing the square root of 16 to the 1 power. And then the square root of 16 is just 4. You can always double check these by typing in 16 using the caret button for the exponent and then 1 divided by 2, and it'll show you that the answer is 4. So you can check it on your calculator. For b, so we're doing the cube root of negative 27 to the 1 power. You might think you're going to get an error, but again, it's what number cubed is negative 27. Well, negative 3 cubed is negative 27. For c, you're doing the 4th root of 81 to the 1 power. And then what number to the 4th power is 81? 3. D is a little bit trickier because we have 2 values here. So we're doing the square root of 4 cubed. Now this one's kind of interesting. You can either square root first or you can cube the 4 first. So I'm actually usually finding the square root is easier. So notice the square root of 4 is 2. Now I'm going to cube it, so 2 cubed is 8. Notice if I did the cube first, 4 cubed is 64, and then the square root of 64 is 8. So you can do it either way, you'll get the same answer. Okay, for part E, you have to kind of squint to see it, but this is 9 to the negative 1/2. Since we have a negative exponent, we have to rewrite it, moving the base of 9 to the bottom to make the exponent positive. So this is 1 over 9 to the 1/2 power. So this can be rewritten as the square root of 9 to the 1 power, and that's on the bottom. And then the square root of 9 is 3. So this is 1 over 3. For F, this is the cube root of 8 to the 2nd power. So again, you can either square the 8 and take the cube root, or you can cube root first and then square it. So I'm going to cube root first. So the cube root of 8 is 2, and then 2 squared is 4. Notice the other way works too. 8 squared is 64, and what number cubed is 64? Well, 4. So both ways work.